Episode 182 of CppCast with guest Arthur O'Dwyer, recorded January 9th, 2019. This episode of CppCast is sponsored by Backtrace, the turnkey debugging platform that helps you spend less time debugging and more time building. Get to the root cause quickly with detailed information at your fingertips. Start your free trial at backtrace.io/CppCast. In this episode, we talk about initialization and C++ feature flags. Then we talk to Arthur O'Dwyer. Arthur talks to us about board games, his 3 ISO C++ papers, and much more. Welcome to episode 182 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
Doing okay. It's like first full week of the new year now, right?
Yeah. Yeah.
So getting back into the normal flow of things, get back in school and all that. Good stuff.
And time for me to make sure everything's ready for C++ on C.
Mm-hmm. Less than a month away now, right?
Yes, I leave February 1st. I honestly can't remember what day the conference actually starts. I'm more paying attention to my own schedule.
Right.
And teaching a class there and giving a talk. And it is official now that I am also giving a class at Core C++, the one that's in Tel Aviv.
Right. And that's
which I don't think I had mentioned that yet.
June or July, I think, right?
It's May.
May, okay.
So it's immediately the week after C++ Now.
Okay.
Which means I'm probably not going to C++ Now, because it would make for a very tight trip.
Yeah, that'd be a lot of travel.
Yeah.
Okay, well, at the top of our episode, I like to read a piece of feedback. This week we got a tweet from Daniel Palestrelli, and he wrote, I'd like to have feedback from your listeners about my modern C++ interactive command line library. And he sent us a link where he actually posted this on Reddit. And it seems like he actually got a lot of upvotes and a decent amount of comments right here on Reddit. And I'll put this link in the show notes. But it's an interactive command line library for C++ applications. And it looks nice because it's for, it's interactive as in you're not just passing command line parameters and then running it. You can continue interacting with the, via the command line while the application is running. So for applications that need to run that way and be interactive, it seems like a good library.
Yeah, what the first upvoted comment on Reddit is like, oh, you should record a session with the ASCII Cinema tool, and oh, that's a great idea. And so I saw that a couple weeks ago, and the article was posted on Reddit. So I was really hoping that there was one now, and I don't see an
Yeah, it'd be nice
video
to see a GIF or YouTube of the library in action.
Yeah, that goes a long way for people that are just like checking out something real quick.
Yeah. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes. Joining us today is Arthur O'Dwyer. Arthur started his career writing pre-C++ 11 compilers for Green Hill Software. He currently writes C++ 14 for Akamai Technologies. Arthur is the author of Colossal Cave, the board game, Mastering the C++ 17 STL, the book, and the STL from Scratch, the training course. He is occasionally active on the C++ Standards Committee and has a blog mostly about C++. Arthur, welcome to the show.
Thank you. Yeah, good to be here.
All right, so how did you make a board game about Colossal Cave? Or maybe you should explain what Colossal Cave is for our listeners who are too young, like Rob.
Yeah, sure.
Yep, I don't know what that is.
Yeah, the one without a beard. Colossal Cave, or Adventure, as it was originally called, I guess. It was just Adventure because it was the original adventure game. It was the text adventure. You go north, enter cave, get treasure, kill troll with sword, that kind of thing. It was the original. Originally, it was the only one, and so it was just called Adventure. or Advent. And then it was widely distributed and imitated, and Infocom, these guys at MIT picked it up and made something called Zork that was kind of based on it, and that turned into a whole series and a business for them. But Colossal Cave was originally just these two guys who one after the other went and created this iconic text adventure. I don't know. You should play it. Right. It's good.
Okay, you made a board game though out of it.
This was back in around 2012, 2013, and I had been playing a lot of the Looney Labs game Back to the Future. I'm big into board games. I do a lot of.
I didn't know there was a Back to the Future board game either.
There is, Back to the Future card game based on Chrononauts for other board game nerds in the audience, and I highly recommend it. It's fun, and it got me thinking that hey, I could take this mechanic and kind of massage it to put it on top of this other thing that I was really into, adventure, and so it's a essentially card game, cards for different items and treasures that you find in the cave. And the idea is you go down into the cave and you get treasures and you come back. And the first person to get 3 wins. And there's a map, a board with the locations that you move around on, and you have to be in certain places to play certain cards or to get certain items. And it's a large element of take that, of you think you're going to get this treasure back up to the surface, and someone else has the bottomless pit card, and suddenly you're in a pit, and you lose your treasure. And so I put that on Kickstarter, and got more money than I thought I was going to get. Like 15,000. So not 6 million, but
enough to print and run.
Enough to print one run and distribute it, and you can buy it on Amazon used at this point. Oh, yeah. And maybe in a decade or so, maybe I'll do a version 2. But it was fun.
I think you are the first guest we've had on who's had a successful Kickstarter, or a Kickstarter of any kind. Rob
really?
Is agreeing with me, I think.
I mean, I don't recall ever bringing it up with another guest, yeah.
There's one other guest that we've been talking about getting on who has had a Kickstarter, but we haven't had him on. Okay, so I've got to ask, for people who are considering that, it's completely off topic, but on topic for your bio. What, how much of a pain was it to, send all the rewards, that kind of thing? You said 2012-ish?
Yeah, 2013.
So that would have been...
That's a pretty early Kickstarter, right?
Yeah.
Yeah. It was when Kickstarter was the new hotness. It was I wasn't a pioneer or anything, but it was right after the pioneers, and they were proving that okay, yeah, you can do this, and everyone's oh, this is awesome. I'm gonna do my own Kickstarter. And what actually happened in my case was there was a game publishing company that started up as a spin-off. Not really a spin-off of Kickstarter, but exploiting Kickstarter, right?
Right.
Selling the picks and shovels to the gold rush. And they contacted me because they were just sort of trolling Kickstarter looking for projects. And they said, we would like to, take 90% of the money in exchange for doing your fulfillment and coordinating with the factory and so on. And I said, that sounds awesome.
Right.
Because... I wanted the thing to put on my bookshelf. I didn't really care about, the millions of dollars I was going to get by, selling this thing. So they picked it up, and so they did all the fulfillment and everything. Okay. And so that, from my point of view, worked out very easily. From my side, I just needed to sort of make a spreadsheet of everyone who had signed up and what they should be getting, and and then send it to them, and they seemed to take care of it pretty well.
Cool.
This is totally off topic, but I will say the one thing that was a little bit of a snafu was I had originally planned to do the game and then an expansion and you could pledge extra money to get the expansion. But it turns out this is not really a good model for a Kickstarter, to have one tier where you get one thing and then the next tier where you get that plus something else.
Okay.
If it's an expansion, because now, you've based on the number of pledges, you've sold 1,000 games and 500 expansions. What do you do with the other 500 expansions?
Right.
So unless you're doing a lot of volume, which I wasn't, what we ended up doing was saying, okay, let's just put the expansion in the box with everything else, because it's actually cheaper to just make one thing. Right. That also, and so everyone got the expansion. And then, of course, everyone who was in the higher tier was like, hey, we paid extra for the thing, and then you gave it to everyone else. So we ended up giving them gift certificates to buy other games through the Game Salute store. And they ended up getting more than they paid for. Everyone got more than they paid for, which was great.
Yeah, I guess that's good for everyone.
Good for the Kickstarter backers, yeah. Yeah. Okay, well, we, to go back on topic, have a couple of these articles to discuss, Arthur. Yeah, that was interesting. Feel free to comment on any of these, though, and then we'll start talking more about the proposals and C++ work that you've been doing, okay?
Yeah.
Okay, so this first one kind of calls back to an article we discussed last week with Izzy. This is Sean Parent's response, which I think we actually referenced when talking about the other article, to the the post by Eris about modern C++ ruminations. So yeah, this is Sean Parent's response, which I guess several people in the community were asking him to respond to this post. And I think we kind of had similar things to say about it last week, which is, the stuff he's talking about is important. C++ compile time and bail time is important. But, the post that he was picking apart, the Eric Niebler ranges post or example, was just really not a great example code. Right.
It seems to kind of be the conclusion of everyone on the internet, was that Eric's example is not a great example.
Yeah.
This IOTA thing, though. Arthur, I'm sure you've been following the IOTA thing.
Yeah, it's like a guilty pleasure, right? It's something no one should be. It's like the Kardashians. No one should be paying attention to IOTA, but it's the one thing to come out of this. I gotta agree with the original post, though, more than Sean Parent's side. It's not really sides. Everyone kind of is agreeing. Everyone's very reasonable people, but the upshot does seem to be that ranges takes 8 minutes to compile, and the examples that purport to show how awesome it is end up not being good examples. I want to see a good example. If the consensus is always, oh wait, that wasn't a good example, someone should show a good one.
There was a tweet, an article, it was a couple weeks ago, where someone said, I showed ranges to my new C++ students just as a concept, didn't show them in a specific example, and they came up with all these great examples. And it was a couple of things listed, and I cannot for the life of me remember who posted that and where it was, but maybe we just need people who don't know what they're doing to come up with the best examples.
And then we need someone who's a super duper expert to look at those examples and figure out if they're right or not, right? Or if they have subtle dangling references,
hopefully
threat on safety, but sure, we all hope we don't, right? For any program, you can say, I hope it doesn't have bugs, but
yeah,
I'm skeptical.
Yeah. So I guess we should give a little bit of we kind of talked around IOTA. Basically, some people are saying, well, the history of what IOTA means is obvious and everyone should know it effectively. Mm-hmm. And other people are saying, well, everything you just said is wrong.
That's not much of a summary. No, I think Eris's original blog post said, something to the, with a bit of exaggeration, right, for effect, said, the IOTA is an example of the cancer that is C++ today, where they're just making up these, look how smart I am, IOTA stands for this thing from APL, and everyone, should just obviously know. We don't call it generate sequence, we call it IOTA because we're cool, right? And Sean Parent was saying, well, really, you should know APL because it's important as a craftsman to understand the history of the profession, and you should know about IOTA, but which is true as far as it goes, but there's always going to be more people who haven't learned that particular thing today.
Right.
It would be nice. Everyone does know what generate sequence means because they know those English words. You have to know two things. You have to know what it does and also why it's called IOTA. It would be simpler if it weren't called IOTA. It just would be simpler. But should we argue about it? No.
If you all will indulge me for just a second, I'm reminded of signs that we just got back from Hamburg right before Christmas. Hamburg, we're in Germany. At the Christmas markets, there's signs that say Pomme, Pommes. This is the French word for apple.
Yeah.
Right? What does that mean? That means French fries to an American. Why? Because in French, they say pomme frite, which means literally apple fries. But that's a shortening of pomme de terre frite, which means apple of the earth, which is potato fries. So it starts from a shortening to a shortening to a shortening, and now we have the French word for apple on signs in Germany, meaning fried potatoes.
French fries.
So that's what IOTA made me think of.
That's fair.
One more thing I just wanted to point out with this article that I thought was interesting before we move on is that Sean Parent says that he will spend weeks writing code without trying to compile it. And
yes.
That just really kind of explains to me why Sean Parent is able to do what he does with being able to look at some code and say, yeah, that's just such and such algorithm. I thought that was pretty interesting.
Yeah, I never spend more than 6 or 7 hours writing code without trying to compile it personally. I never go into multiple weeks of thinking about it because I have to get past this mental hurdle to know if the thing that I've tried so far is right. Mm-hmm. I might end up rewriting it again, but otherwise it's difficult for my imagination to move past that.
Okay, so next article we have this is another one that might have a lot to say about it. Initialization in C++ is seriously bonkers, and this is from Mike Liu, who said, just start with C as a subtitle, which I know is not going to be an opinion that we all agree with, but there definitely is a lot of craziness with the C++ initialization that he points out in this article, along with the great GIF that's at the top.
Yes.
Yeah, and hopefully you've maybe seen this GIF online already if you are on Twitter or anything, but it's clips from Forrest Gump where, I can't remember the name of the character. Bubba is talking about all the different types of shrimp, only instead he's talking about all the types of C++ initialization. It's great.
Yes.
I would say the GIF is better than the article.
I think the author even says that. He's like, yeah, just watch this GIF instead. You don't need to read the article. Yeah.
It makes things can be very complicated. I feel like it's making it maybe a little bit more complicated than anyone really needs to know. It's a problem that it can be made so complicated. It should just be simple. There should be no way to make it complicated. But a lot of these examples I felt like were things that people wouldn't even run into in real life. Right? And there's plenty of things that people do run into in real life that you could complain about.
Right. Maybe, that's a good thought there. Let's focus on the things that people run into every day and try to make those better.
And I'll say, Jason, you had a great talk at, I believe it was C++ Now, this past year, right? On initialization and initializer list.
Yeah.
And all the things that it disables move semantics and has issues with deduction. And I forget all of the issues, but that was I was in the room for that, and it was highly entertaining then. I don't know how it translated to YouTube, but I recommend everyone go back in time and go to it for sure, and possibly watch it on YouTube.
Yeah, initializer list. That's something that annoys me as a teacher. Initializer space list versus initializer underscore list. I'm referring to the initializer underscore list, which is the type that is created for you when you do list initialization of something like vector. It just hides too much machinery. Yeah. That's my overall complaint for that one, but yeah.
Okay, and then we can move on to this last article. Well, not really an article, it's actually just a GitHub repo with just one C++ source file, but it's something that could be pretty handy. If you compile this, you'll find out all of the features that your C++ compiler will support.
Yeah, that's pretty neat.
Yeah, and it'll just say this feature, which is a C++ 20 feature, is or is not supported. So, yeah, seems pretty handy.
I only have one question about it. At the very top, it starts with if indef __ has _ include. I don't think the standard requires that has include is a preprocessor macro that you can test for. And I don't know if Arthur has an opinion on that or not.
I would be very surprised if it were a preprocessor macro you could test for. But I did actually go and I ran this code on Compiler Explorer with a couple of compilers and was pleasantly surprised that it compiled. So yeah, I mean, all the vendors seem to agree then that has include should be a pound define, basically. You know, that idiom should work, which I think is great because it was not that long ago that a lot of these header files, like they're just saying if this include file exists, then include it. And it wasn't that long ago that including a file that wasn't supported, would give you it would have a pound error in the middle of it, saying you need C++14 to include this file or something. And then if you include it at all, your program just dies. And the library vendors have been moving away from that. Now they're moving to something that I don't really like, which is just no ops. Like you include optional, and it just doesn't have any code in it.
Well, because it all has to be compiled away, if it's not in the right
I wish there was some way for the vendor to actually say, like, well, if you're in this mode, then this header doesn't exist, and then you would actually be able to say, oh, okay, the header doesn't exist, I'll go include a different header, This way you have to say, okay, I'll include the header, it'll all get if-deffed out, I will test this other macro to find out whether the feature was included by that header, find out whether there was any code, and then I can go include boost optional or whatever my workaround is. It's still a complicated dance, but at least it is moving to be a dance that always works. As
C++ is simple, right?
Yeah.
Okay, well, Arthur, as we said in your bio, you said you are occasionally active in the C++ Standards Committee. Do you want to tell us a little bit about the proposals you're currently working on?
Sure. So the big one is trivially relocatable, but I almost wonder if we should start with the smaller one.
Start with the smaller one, yeah.
Let's start with the very smallest and then work our way up. So I have one that I am trying to push for, which is just type traits for this new structural comparison stuff that's coming. Operator spaceship, right? The less than, equal, greater than, three-way comparison operator. You can equals default the comparison operator to get the compiler to generate it for you, and then it will deduce the appropriate, strong ordering or weak ordering or whatever. Weak ordering is a dumpster fire, by the way, but it should always deduce strong ordering. Let's see, and then if you equals default your comparison operator, then it becomes, at least if it's defaulted all the way down, it becomes what's called a structural comparison operator that then allows you to use the type, if it's appropriately const expired, you can actually use it as a non-type template parameter, right? And so this allows you to write your own types that are then usable as template parameters, which is something that we have not had before.
Right.
You could use them as regular function parameters, the const exp for functions, but not actually template parameters themselves. However, you could only do this if the comparison operator is structural. And you might say, how do I know, or how do I verify that my comparison operator is structural? Equals defaulting it is not quite good enough, because if one of my base classes or one of my members doesn't have a structural operator, then my operator isn't structural. And the compiler knows, of course, whether it is or not. But it would be very nice to have a way that I could static assert that this property held for my class, because it's a relevant property. Rather than writing some sort of clever code to detect this, I would like to just be able to static assert it. I might even have code that wants to switch on, if it's structural, I can do this version. If it's not structural, I do this other version. I don't know of any use cases for that, but just having this type trait available, having an is, I forget what I call it, has structural comparison. It's in the proposal. So that's a little one.
Oh, is it? So I guess before we move past that, what's the status of the little one within the standards committee?
Well, I've gotten Jeff Snyder, who is one of the principal authors of the original structural comparison non-type template parameter thing, to say, yeah, this is a good idea, and to be a co-author.
Okay.
But it was being looked at by the new LEWG incubator, I believe, as of San Diego, which I wasn't at. And I'm going to be in Kona and hope to be pushing some of these a bit more there. There was also some debate over it originally that the LEWG didn't want to see it because they said, well, this looks like compile time programming. Shouldn't this go to the reflection study group? And the reflection study group, of course, said no.
No,
it shouldn't. We don't want to see this. But, so they ended up playing ping pong with it for a little bit.
I don't see it's any different.
Who has jurisdiction?
Yeah, I mean, there's so many type traits. I just wouldn't see how it's different from any other type trait, really.
I think it was more that LEWG didn't want to deal with it.
Oh, okay.
It was a good excuse to have someone else deal with it. But that person didn't want to deal with it either. So the other proposal that I have going, which I have probably the best hopes for, I think, as far as trying to get it into, hopefully, C++20, we'll see, is something called More Implicit Moves, which is P1155. And the point of this one is, about RVO. I gave a talk about RVO at CppCon, and I recommend everyone should go watch it, at least if you want to know what I'm talking about for the next 5 minutes. Well, it was weird because when I gave that talk at CppCon, I actually thought I had signed up for an hour-long slot, and it turned out it was a half-hour slot. Totally my fault that I didn't know this going in, but it had to be a little bit improvised.
At what point did you realize you only had half as much time?
Oh, like as soon as I was on the stage and the AV guy came up to me and said, "We're going to need you to get off the stage real quick," at the end of because the next guy's coming up, and I went, well, that doesn't seem normal.
So literally like a minute before you're ready to start your talk. Minutes before.
Yeah. So
all right.
I just kind of raced through some of it. But anyway, so RVO. So the general rule of thumb these days, and really for the past couple of decades, has been if you say return X, semicolon, that's probably as efficient as it's going to get, right? You shouldn't do anything weird. You shouldn't say return std_move of X. Like, that's never going to be faster, right? Because
probably never going to be.
It sounds like you've seen my talk. Well, it should never be, right? Because either with return X, either X is a local variable, and therefore I should be getting return value optimization, right? Copulation.
Right.
Or X is something like a parameter or something that can't be copulated. But even in those cases, I get what the standard doesn't really have a name for this, but I'm calling it implicit move.
Right.
Where instead of calling the copy constructor, it actually calls the move constructor to construct into the return slot. However, this doesn't fire in a lot of cases, a lot of different kinds of cases. In most cases, 90% of the time, 99.9% of the time in real code, it will fire. Because it will look for a constructor that takes an R value reference the type of X, basically.
Okay.
And then if that exists, it will call it, and if not, it falls back to copying.
Right.
So the problems are, what if the thing that it finds is not a constructor, but a conversion operator? If I have an R value qualified conversion operator, it's not going to find it.
Okay.
Right? Or it's going to find it but ignore it, and it's going to use the copy constructor instead. What if the constructor that it finds, it does find a constructor, but the type of the constructor's parameter is not R value reference to the type of X, but to a base type of X.
Right.
If X is a derived class, and I'm returning an instance of the base class, rather than moving from X into the the base return slot, I will actually make a copy. And that can be quite expensive. That was the case that I ran into in practice. And is covered also in the talk. And then it needs to be an R-value reference. So if you have a converting constructor that takes its parameter by value rather than by R-value reference, and actually taking things by value in constructors is something that we're taught these days to do.
Right.
So if you do that, then again, that's not an R-value. And so you'll get a copy. And in all these cases, there's no real reason, like there's no physical reason that a copy would be better, and there's no physical reason that the copy has to happen, for technical reasons. It's just that in the paper standard, the wording is very specifically looking for R-value references and constructors, and not conversion operators, and not by-value sinks and that kind of thing. So my proposal basically says, let's cut about half of this paragraph, all of these words that add pessimizations to existing implementations without providing any benefit. Let's just cut those words and say, here's what we're going to do now. We're going to look it up like it was an R value, and if that works, we're going to do that. And otherwise, we'll look it up as an L value. And that's it.
Just on any return statement?
Any return statement of the form like return X, where you're returning something by name.
I'm wondering if that would also apply to the issues that I've hit with returning subobjects, return x dot s or whatever.
My proposal would not change that. Okay. I know that Antony Palukin, whose name I may or may not be pronouncing right, had a couple of proposals going into San Diego, but I think they were not well received, because that is a very hard problem. Right.
It seems like it could. It sounds to me like your problem could address that, though, because then if the x part of that still becomes an R value, then the .s would become an R value, and everything would work like you wanted it to.
Well, you can't do that for arbitrary expressions. For dot, maybe. But suppose I had return like x plus x, right? I have a double function.
Yeah, no, you wouldn't want to do that.
Takes x and returns x plus x, and if it's a string, it concatenates the string with itself. If I turn those x's into R values, then yeah, that would just totally blow up. So
no, but the result of that's already going to be an R value, and what you want is going to happen already.
No, because there I'm adding an L value to an L value.
Yes, but I'm saying the result of that expression is an R value, so it's going to properly construct the return value.
Yes, but if it knew that X was an R value going into operator plus, it could maybe reuse its buffer. Now, because you're adding it to itself, there's an extra wrinkle there, and it probably wouldn't happen in real life. But
right, okay.
The idea is you can't just turn every identifier into an R value, because it might be needed later.
Okay. I see what you're saying.
Right?
Yes.
In the same expression, it might be needed a second time, and you have no way of knowing that, so you can't just go willy-nilly turning things into R values.
Right.
But specifically in the case of return X semicolon, right?
Right.
I think
a named value.
Yeah, we have an intuition that serves us well most of the time, that X is actually going to be either moved from or not exist at all because it's been copy-elided.
Right.
In that specific case. And so all I'm trying to do is patch the holes in that intuition, because there are cases where you use that intuition and it actually doesn't work. You actually get a copy. I want those to go away. I don't necessarily want to create new cases where you have to learn a new intuition that, now I see it's going to get moved in this case. Okay. You want to take the intuition you already have about it being moved and just make sure that actually happens.
That sounds fun.
There's also a related case that David Stone has a proposal that I think is going to core in the next meeting that deals with return X, where X is actually a parameter or a local variable of R value reference type. So if I take an R value reference parameter, string ref X, and then I say return X, that will actually move out of X. This to me is actually scarier than what I'm proposing.
No, that sounds dangerous, because you may never... Just the fact that you have an R value reference does not mean that you ever wanted to or intended to move. I mean, that's something that might be moved. It is not something that is going to be moved.
Well, he's making it something that is going to be moved. I mean, you are returning it. So, you're going to be either getting a copy of the value or if the return type of the function is like string ref, and x is a string ref, it makes sense that I should be able to return x. Yeah, it's, I think, less intuitively obvious. Like, it feels a little bit unsafe to me, but I believe that the evolution working group thought, okay, sure, let's do it. And it would make certain idioms a little bit easier. Things where you return decal type auto.
Right.
Wait, does that work?
Well, no, that would actually change the meaning of return decal type auto in some cases from what it currently has. That could be a breaking change.
From returning an L value to an R value, yes.
Yep.
But that one is progressing, and so I have hope that my more conservative one, which, he's proposing this one thing about R value references, I'm proposing this other thing about regular old values, and I'm hoping that they will sort of progress together, and we'll end up with both.
Well, hopefully they are both fully considered their impacts on each other if they both get through.
Right. Yes, my paper actually has two wordings. It has a wording against the current draft and also a proposed wording that's a diff against David's proposal.
Okay.
That says if his gets in, here's what we then remove, like even more code, remove even more text from that paragraph to enable things like conversion operators and by value parameters. So I'm hopeful for that one.
Okay.
I wanted to interrupt this discussion for just a moment to bring you a word from our sponsors. Backtrace is a debugging platform that improves software quality, reliability, and support by bringing deep introspection and automation throughout the software error lifecycle. Spend less time debugging and reduce your mean time to resolution by using the first and only platform to combine symbolic debugging, error aggregation, and state analysis. At the time of error, Backtrace jumps into action, capturing detailed dumps of application and environmental state. Backtrace then performs automated analysis on process memory and executable code to classify errors and highlight important signals such as heap corruption, malware, and much more. This data is aggregated and archived in a centralized object store, providing your team a single system to investigate errors across your environments. Join industry leaders like Fastly, Message Systems, and AppNexus that use Backtrace to modernize their debugging infrastructure. It's free to try, minutes to set up, fully featured with no commitment necessary. Check them out at backtrace.io/CppCast. And then you have a third paper, Trivially Relocatable, right?
Trivially Relocatable, yes. Man, where to start with this? Hey, one of you guys should. Can you summarize this paper? And then I can just correct you. Wouldn't that be
You're
awesome?
the author. I don't know.
Yeah, I haven't actually read it yet, I don't think. But I've heard mentions of it for a while.
Yeah. So yeah, this is an idea that's been around in one form or another for a very long time. Most recently in history, Pablo Halpern, around 2014, I think, had a series of papers called Destructive Move. And this is similar, but I think more conservative and more performance-oriented than Pablo's Destructive Move. The idea here, think about vector resize or vector reserve or pushback or any of these things that reallocates the vector. Let's say I have a vector of int and I reallocate that vector. I make a new memory buffer and I just take the ints from the old buffer and copy them over into the new buffer and then I deallocate the old buffer. And if I were dealing with like strings, that wouldn't be a correct implementation because I said copy and I didn't say anything about destroying the old ones. But in case of int, I can actually just literally memcopy the data from the one buffer to the other, and then I can just drop the old buffer on the floor by deallocating it. I don't need to call destructors.
And currently,
it's trivially copyable.
Well, I was just going to say, just for the sake of our listeners, currently standard containers take advantage of this with the is trivially copyable trait.
Yes.
Okay.
But if I had and this would work also if I had like int star. Int star is trivially copyable, right?
Right.
But as soon as I give it some RAI features, as soon as I give it a destructor, move constructor, if I have unique putter of int, and I have a vector of unique putter of int, and I reallocate it, suddenly I don't use memcopy anymore. Now what I'm going to do is I'm going to use the move constructor of unique putter to move construct each unique putter from the old buffer to the new buffer. And then once I'm done moving them, then I can go back and call the destructor on every one of those unique putters in the old buffer, which of course it's nulled out at this point, so the destructor doesn't do anything, but I still call it. And even if it gets inlined, we can see that compilers are not perfect at this. You might think, oh, well, the destructor is obviously a no-op. It should just obviously not do anything. But in practice, no, compilers, if there's a loop with a function call in it, they're going to do something that's not nothing.
Probably.
You can go on Compiler Explorer, and the paper actually has links to several Compiler Explorer.
Well, I didn't mean to be terribly contradictory. It's just I have a bunch of examples in my training material, and I've noticed that every 6 months when I go to teach the same class again, I'm like, oh, well, now Kling's optimizer is actually doing this, so it's a bad example now. So, yeah.
Yeah, but you don't usually have to tweak it that much, I would think, to make it back into the bad category.
Yeah, it depends, but yeah.
So vector of unique putter, reallocating.
Right.
But if you think about it, you could actually use memcopy to reallocate a buffer, the vector's buffer of unique putters, right? If I just used memcopy and copied the pointer values from the old buffer to the new buffer, and then I deallocated the old buffer.
Without calling the destructors.
Which
currently is undefined behavior to free an object without calling its destructor if it's not trivially destructible.
I don't think that's technically true. I mean, it's certainly not something that you would think is a good practice.
It is. I believe that's true because it comes up in the case of non-virtual base class destructor is technically undefined behavior.
Well, the thing about non-virtual base class destructors is if you delete through the pointer to base at that point,
yes,
that's not only undefined behavior, but it's actually wrong because you're going to be the delete operator is going to be handing some memory back to to malloc and free or wherever your heap is, and it's going to be handing back the size of the base object, not the size of the derived object.
Oh, okay. So
and it's actually going to corrupt your heap by doing that.
Okay.
So I don't even know if that's undefined behavior, but it's certainly, it's going to crash, right? So there's a reason that should be undefined behavior or something.
Right.
In the case of just handing back the memory, as long as you hand back the right amount of memory without calling the destructor, I mean, maybe from C++'s point of view, the object is still in some sense there. I don't really know. Maybe it's undefined behavior. But anyway, this is certainly the thing that's really undefined behavior here would be I'm doing the memcopy into this uninitialized buffer, my new buffer, right? I'm memcopying a bunch of data in, and then I'm just saying, I'm going to assume these are unique putters. I'm going to treat them like unique putters, even though I never constructed a unique putter there. I just memcopied some stuff into a newly allocated buffer. So yes, this is totally undefined behavior. And so library vendors today don't do it. They're very scared to do this optimization, which means if you have a vector of unique putters and then you resize it, it's going to be slower than if you used a library implementation that wasn't scared to do this optimization, such as EASTL, BSL, Folly, all do this optimization. In fact, Folly's FB vector, that's Facebook Folly, Folly's FB vector actually enforces, in the docs for FB vector, it says your type must be trivially relocatable.
But since that's not a trait that currently exists, how do they enforce that? Like, how do they know whether it's something that can be done?
They enforce it by, if you get it wrong, then you have a bug and your memory probably gets corrupted.
Okay, so there's no real enforcement.
Yeah, they have no way of verifying that a type is or is not trivially relocatable. And for example, by the way, like unique putter is trivially relocatable, shared putter is trivially relocatable, string is generally trivially relocatable, but there are cases, function is one that actually differs between libc++ and libstdc++. Std function, a common way of implementing the small object optimization, where you take the original object that you're wrapping in the std function, and normally that would be heap allocated, but you can also put it inside the body of the std function object itself. And when you do that, the internal pointer that the std function object holds to the controlled object that pointer can point into the body of the std function itself. And then when you move the std function,
right,
you have to update that pointer to point to the buffer inside the new destination object. And so you can't do that with memcopy.
Okay.
So I forget which is which, but I think libc++ does that with the internal buffer, and therefore is not trivially relocatable, whereas GNU's libstdc++ std function actually is trivially relocatable.
Okay.
I think that's the right way around. The paper says for sure. And so, yeah, you can have these cases where even a standard type that exists on two different platforms but actually has different behavior in this respect. And so, if, for example, you're using Folly FB vector and you have a vector of std function, that could work totally fine until you change your platform and you go to Apple and suddenly it doesn't work anymore. It worked fine on Linux. It doesn't work on Mac OS, right?
Right.
Because there's no way to static assert this property. And so what my paper is proposing is a family of type traits. Std is trivially relocatable v, that kind of thing, that you can ask, hey, compiler, do you know that this type is trivially relocatable? And then that would be true for things like unique putter and shared putter and string and so on, and function when it is and not when it isn't. And so you could actually static assert it or switch your behavior depending on whether it was trivially relocatable or not.
It sounds like something that the compiler could not automatically determine, like just based on your std function example. Like how does that work?
So the compiler can determine it in a lot of cases.
Okay.
Right? If you just have an aggregate or something where the move constructor and the destructor are defaulted.
Right, yeah.
Then you just look at the members and you look at the bases and you propagate the information in the logical way.
Right.
And the paper has core language wording for how that works. But it's very, it's obvious. It's just the same as trivially copyable, right? So in a lot of cases, the compiler can tell. The problem, is what happens if I have something that does have a user-provided move constructor and or destructor?
Right.
In those cases, the compiler has to conservatively assume that the thing is not trivially relocatable.
Okay.
So then we need an opt-in mechanism for the programmer or the library vendor, whoever it is, to say, hey, compiler, I know you're going to assume that this is not trivially relocatable, but I promise that I have done the work and made the proof or whatever that says that my move constructor and my destructor are, they mesh together in the proper way such that I preserve trivial relocatability. So we need a way to warrant to the compiler that you've done that work. And in my proposal, I propose this be done through an attribute.
Okay.
You're supposed to gasp at this point.
Nah, I don't care. Attributes are everywhere now, so
yeah, that's
sure,
what
an attribute.
Yeah. So you put the attribute on the type, and you attribute trivially relocatable, and that tells the compiler that it should ignore its normal conservative estimate and just assume that your type is trivially relocatable because you said that it was.
Okay. I'm not going to gasp. Sounds like an idea.
And I've got examples both in the paper and in a fork of libc++ that show how to do this, like conditionally, right? Because you have to, for example, for std vector is normally trivially relocatable as well because it just has a couple of pointers in it, right?
Okay.
But those pointers actually aren't necessarily pointers. That's the allocator's pointer type, and it could be some wacky thing, or the allocator itself might be some wacky thing.
Right.
So you have to do some metaprogramming.
So if you use like a stack-based allocator or something. Yeah.
Yeah. Well, even that's probably fine because it's just the allocator is just a pointer to a heap. I have a talk about that too. You should all go watch that.
Right.
An allocator is a handle to a heap. But that handle type itself could be
I think I saw
something
that one.
wacky. Yeah.
Live.
So you have to do some metaprogramming to say, if my allocator's pointer type and my allocator are trivially relocatable, then I am trivially relocatable. Otherwise, I am not.
Okay.
But that metaprogramming is fairly mechanical. It's something that certainly library vendors would be used to doing. And we're looking at ways. I think that's the biggest area of possible evolution in this paper is maybe the attribute should take a Boolean parameter that could just be true or false, and you can put all your metaprogramming right in the argument to the parameter and not have to mess around with conditionally relocatable base classes and things.
Are there any conditional attributes currently?
There are no standard attributes that take this conditional parameter, but there are several that have been non-standard attributes that have been done by Clang, and I think also by GCC.
Okay.
There's a non-standard enable if attribute that works just like std enable if, but is faster. And Clang also has diagnose if, which is used for things about versioning in the Apple headers. And there are attributes that take a parameter also, things about alignment. I think the assume align that just got in, I think that's done with an attribute, and I think it takes a parameter.
Well, and
maybe don't quote me on that one.
Contracts will have that kind of thing all over the place.
Contracts, well, pet peeve of mine. Contracts are they're officially attributes, but they're not because they don't follow the attribute grammar.
Oh, well, I didn't realize that.
They half follow it, right? They've got the square brackets around them, but then instead of having parentheses for the argument, they have a colon. Right. Expects colon and then an expression.
Right.
So that's not really following the attribute grammar.
Okay.
They're a separate thing that is called attribute in the standard, but it's not. Compilers are not going to call them attributes, but the paper standard is going to call them attributes, but it's going to be a separate kind of attribute. I don't think contracts are ready. I don't think a lot of things are ready.
Well, still some time to iron out all that stuff, right? Hopefully.
Yeah. I wish that the standard would go back to an 8-year release cycle.
Really?
I mean, it was before my time, but C++11 ended up being pretty awesome, right?
Yeah, but that was completely accident. They wanted to release it much sooner than that.
Yeah, well, I think we should go back to having accidents then. The problem now is we've been sticking to the 3-year schedule, and every 3 years it comes out and people go, what? We voted for that?
I remember waiting for C++ OX to come out for 4 years. Okay, what's going to happen with this? So I'm not sad that it's moved to a faster schedule.
Well, I think one of the reasons, I guess, that C++11 looks so awesome is because C++03 was so bad, right? Because otherwise, what I would say to that is, you were waiting and waiting and waiting, but at least in the meantime, you could just use C++03 and everyone knew it. And you could actually have people who graduated college using C++03 and they could go get a job using C++03, right? That was amazing. These days, you can't even get a 4-year degree without having a couple of releases of C++ in the middle of it.
Yeah, that's right? What college is about, is learning how to learn new things. So,
yeah, but you have to learn how to learn them first. It's just throwing you right in the deep end, saying, no, you have to go out and learn this thing. Whereas if we went back to an accidental schedule, where we said, people stop calling it C++20, I try to call it C++2A. That's my pet.
Oh, well, then you must hate all my most recent C++ weekly episodes, because I'm just calling it C++20 all over the place. I'm whatever.
Everyone does, but I'm really trying to stick to the the old 0x, and then there was 1y and 1z, and now everyone's just oh yeah, it's just 20. We've gotten used to saying, oh well, it's going to come out in 3 years, but we've also gotten used to saying it's going to come out in 20 and maybe it'll have this feature and maybe it won't, and I hope we don't have, I hope we have time to figure out all of the kinks. We've got time. We've got a whole year before it's going to be frozen. That's plenty of time to figure out all the problems with it. But historically, I think it has not been. I think we have problems with things like structured binding. We have problems with the constructor template argument deduction. Problems with half of PMR apparently getting left out by accident. And I think if we went back to making mistakes and slipping, and saying, oh wait, it's actually not cooked yet, and then being real apologetic and everyone getting mad about it, but producing the next C++11 in the process. And in the meantime, people could graduate college using C++17 and get a job using C++17 and actually, catch up. That would, I feel like I want that. I know it's not going to happen, right? but
I will say all of the issues that we have with initializer list happened with C++ 11, and that was after all that extra time of baking. So that might not be the end solution.
That is a fair point. There's plenty of stuff that was in 11 that was problematic as well. I mean, error code. That's fair.
So anyhow, go ahead.
Yeah, I mean, I think the way that we ended up dealing with that is just basically people ignored a lot of 11. Yeah. Which is hard with the initializer list thing in particular, but there's a lot of pieces of 11 that people just ended up not caring about. And I think we're seeing that also with things that come in 17, and people go like, oh, well, I just won't use that piece. Which is fine. That is the way it's always been. But I just don't want the number of pieces people aren't using to outweigh the number of new pieces that people are using. Otherwise, what's the point of adding things?
Right. So
I was going to say we're running out of time, but is there anything you want to plug or mention before we let you go today, Arthur?
Sure. Not a whole lot. But
you didn't get a chance to talk about your book. You wrote a book about C++ 17 STL, right?
I did buy a book. I did write a book. People should buy it.
We also didn't mention that you publish an article about 3 times a day on your blog.
Yeah. I think there was actually one day where I did do 3 in a single day, but that is uncommon. No, it's getting less common now, actually. I started it because I was, just had so much stuff that I wanted to spew out into the world, and it seemed like that was the right place to do it. So I was very prolific early, and now it's slowing down, and I'm getting more conscientious about having to actually think about things before I to say them a little bit. Makes it take a lot longer. I'm working on a post right now about covariance and contravariance, and I sort of put it down for a couple of days because I was like, this makes no sense and is disorganized. So in the old days, I would just put it right up. But yeah, I have a book, Mastering the C++ 17 STL. If you like my blog, you'll like the book. If you want to learn C++ from the ground up, don't buy that book. Go buy a tour of C++ or something instead. But it's a sort of eclectic, it's organized like a tutorial, going through each chapter of here's something the standard library has. It's got a chapter on algebraic data types. It's got a chapter on the new file system stuff. It's got a chapter on PMR. But the content is essentially stuff that I feel is interesting to know about. And I think there's stuff there for, especially for people who think that they know the language, or at least are a C++ 14 expert, but are maybe a little bit shaky on 17. Then I think it would be a great read. And after I wrote it, I realized there is no chapter on string. I just left out strings and string view entirely. I don't even feel bad about it because I didn't have that much interesting to say about them at the time. Yeah, if I ever do a second edition, I should probably put in a chapter on strings. Yeah, so I have a book, I have a blog. I am giving a talk at the New York C++ meetup tomorrow night. So this probably won't even be up by then.
Yeah,
but yeah.
Out already.
Another use for that time machine. They can go back and they can see your talk about initializer list, and then they can go see my talk about concepts in New York. And I'm hoping the New York meetup picks up. I was the organizer of the San Francisco meetup when I was out there, and then I moved to New York in November, December. This past year, so I haven't been out here very long. And I'm looking to get the New York meetup started up, doing regular, at least like monthly things. And so if there are viewers out there, listeners out there in Radioland in the New York area,
I know we have at least some.
Join the Slack channel. Yeah,
sure we do.
Where approximately? I mean, New York's big.
Manhattan. I mean, where is everything, right?
Okay.
Yeah. I mean, I actually live up in Yonkers, which is unfortunate for not a whole lot of C++ people this far north, but the meetup has been meeting at the MongoDB headquarters in Manhattan.
Okay.
And yeah,
Cool.
Okay. Well, it's been great having you on the show today, Arthur.
Yeah. Well, thank you for having me. Thank you for letting me talk and talk at you.
Thanks for coming on.
Yeah.
Thanks so much for listening in as we chat about C++. We'd love to hear what you think of the podcast. Please let us know if we're discussing the stuff you're interested in, or if you have a suggestion for a topic, we'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. We'd also appreciate if you can like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at Lefticus on Twitter. We'd also like to thank all our patrons who help support the show through Patreon. If you'd like to support us on Patreon, you can do so at patreon.com/cppcast. And of course, you can find all that info and the show notes on the podcast website at cppcast.com. Theme music for this episode was provided by podcastthemes.com. Website at cppcast.com. Theme music for this episode was provided by podcastthemes.com.